Experiment OC2A, to separate an insoluble solid and a liquid by filtration. In this example, we will separate soil and water. Firstly, we fold the filter paper. And an easy way to do it is to fold the paper in half and then fold it into quarters. And then if we open the first section, it forms a nice conical shape which will fit inside our filter funnel. The funnel is placed on a conical flask and the mixture to be separated is poured in. The soil is unable to fit through the filter paper, so it is kept behind and is known as the residue, and the clear liquid which pours through is known as the filtrate. In this case, the filtrate is water and our residue is soil. That is the end of experiment OC2A. Experiment OC2B, to separate a soluble solid and a liquid by evaporation. In this experiment, we have a solution of salt and water, which we will pour into an evaporating dish. The dish is carefully placed on top of a water bath. The water in the water bath is being heated by the Bunsen. It turns to steam. The steam heats the dish, and the water in the dish will evaporate, leaving us with the salt. About 15 minutes have elapsed, and in that time, the water has evaporated, leaving us with the salt inside the dish. And as you can see, the salt has crystallized out, and the water has evaporated. So we have successfully separated salt and water by evaporation. That is the end of experiment OC2B. Experiment OC2C, to separate two substances by distillation. Safety glasses must be worn as there are chemicals involved. In this experiment, we are going to separate a mixture of alcohol and water. The reason why this method works is that the two substances being separated have different boiling points. It can also be used with substances such as salt and water. What we're going to do is we're going to heat the flask, and the alcohol will boil at 78 to 80 degrees. The alcohol will change state from a liquid to a gas, and it will travel up the tubing and down through this pipe here, which is known as a condenser. So before we start, it is important that we switch on the condenser, which simply involves turning on the tap, and the water will flow in the bottom, up through the condenser and back to the sink. This flow of water ensures that the condenser is kept cool throughout the experiment. We will switch the Bunsen to the blue flame by opening the collar. We will now gently heat the mixture and monitor the temperature as it rises. We do not want the temperature to reach boiling point of water, which is 100 degrees. We merely want it to reach 78 degrees. A liquid can be seen forming in the condenser now, and that liquid is the alcohol vapor, which has travelled down into the cold condenser, where it has condensed back into alcohol liquid. The liquid is forming in the graduated cylinder, and our separation is going nicely. Again, the condensation can be visibly seen in the condenser. It is important throughout the process to monitor the temperature of the thermometer, that it does not reach 100, as at that temperature both liquids will boil. We merely want it to reach 78 degrees. At that temperature, the alcohol will begin to vaporize. I have put in some anti-bumping granules to ensure that the solution boils smoothly. And as you can see, the alcohol is beginning to boil, so I will remove the heat. All the alcohol has now boiled and has travelled over into the graduated cylinder. The liquid that travels over is known as the distillate, in this case alcohol, and the liquid which remains behind, in this case water, is known as the residue. That is the end of experiment OC2C. Experiment OC2D, to separate the colours in ink by paper chromatography. The idea behind chromatography is that different colours have different solubilities in different solvents. For this experiment, I'm going to use a black water-soluble marker. I will place a small concentrated dot on the chromatography paper, and to make it more concentrated, I repeatedly dot it a few times at the same point. The chromatography paper then is lowered into a jar in which the solvent's level is below the level of the dot. We will now wait 10 to 15 minutes to allow the water to travel up the paper by capillary action. About 10 minutes has passed. We will now look at the chromatography paper. The dot which we placed at the bottom has disappeared, and we can see that there is an orange streak followed by a red, and at the top is a bluish streak. The separation was caused because these three colours have different solubilities. Orange was the least soluble and blue was the most soluble. As a result, we can determine that the black marker I used initially was composed of three colours: orange, red and blue. That is the end of experiment OC2D.